My name is Dr. Jason Whitham. I co-instructed Bit 477-577, a bioinformatics course on metagenomics with Dr. Carlos Coyer in the fall of 2020. We used Hypothesis, a tool for online group annotations of journal articles to expose students to vocabularies and concepts we would use in our course. Based on our experience and the data we generated from student annotations, we, including Dr. Erin McKenney, have devised strategies for improving student engagement. Today I will present to you leveraging instructor involvement to enhance student engagement via social annotation. Previous research demonstrates the utility of social annotation for close reading, particularly in the humanities. However, student behaviors and benefits are less well documented in STEM, and the impacts of instructor delivery and implementation are not generally considered. Here we assess student annotation behaviors in the presence versus absence of instructor engagement using Hypothesis, a free online annotation tool. Our results suggest that instructors can impart a high-impact, low-touch effect by modeling annotation behaviors to facilitate early conversations. In this session, attendees will learn how to assess student annotation behaviors, evaluate the impact of instructor intervention, and design a hypothesis annotation assignment to promote student engagement. The course that I co-instructed, Bit 477-577 Metagenomics, is an upper division undergraduate and graduate half-semester lab module offered at North Carolina State University, a large public land-grant institution. The prerequisite for the course is a semester-long molecular biology course with an associated lab. In the fall of 2020, the course had 13 students, including undergraduates and graduate students. Graduate students came from a variety of master's and PhD programs. Our main challenge in the course was figuring out how we could get students to analyze complex microbiome datasets online and asynchronously during the pandemic, with the understanding that these students had a wide range of familiarity with bioinformatics. With that, we wanted to introduce students to metagenomics vocabulary and concepts with assignments and hypothesis. We wondered, how can we encourage annotations and sense-making without setting arbitrary goals with the assignments? We wanted to create student engagement in the process of learning metagenomics vocabulary and concepts during journal article readings. We tried using hypothesis and learned from the experience. To tell you more about this, we'll follow this outline, starting with our thoughts about why critical reading is important, telling you a little bit about the tool we chose, Hypothesis, and showing you how to get started using it. Then I'll discuss what we hope students would get out of the experience, a concern we had about sustaining interactions, and analysis of the actual data from the fall 2020 students. I will also share strategies we came up with to improve engagement based on our results. And lastly, I will recap the goals of this session. Why is critical reading important? With an advanced subject like metagenomics, students may be new to vocabulary and concepts in the field. Background information may be very important for learning. Without applications and scientific stories, it's easy to get overwhelmed with details of bioinformatics tools. Critical reading helps students answer questions like, why should I care? How does this relate to me or things that I understand? What kind of questions are people asking in this field? Before getting into the weeds of how does one answer questions with bioinformatics applications, what is Hypothesis? It's an online tool which made it very useful for teaching during the pandemic, engaging participants in asynchronous assignments. It's also very useful in a post-pandemic world. This is because it makes collaborative annotations of journal articles easy. Groups of students can collectively summarize procedures and findings, and instructors in theory can facilitate co-creation of understanding by adding their own annotations. Here is a short video demonstrating how to begin using Hypothesis. Dr. Goller will first demonstrate how one obtains an account and adds the Hypothesis tool to their browser. Go to web.hypothes.is and click Getting Started. Once you have an account, you can search for an article and begin annotating or highlighting text. Here, Dr. Goller clicks the text and chooses Annotation. This opens a bubble similar to comments in Word. For more information, please see the Hypothesis documentation. So what did we hope that students would get from the group annotations of journal articles? Group context goes beyond a simple reading assignment. Yes, students learn vocabulary and concepts, but we also wanted them to be exposed to the diverse perspectives of other students without spotlighting them, encouraging participation by all students by normalizing struggles, and help them practice data management skills with consistent tags for classifying and organizing references. To realize our vision, we recognized that there needed to be actual conversations, but that creating and sustaining interactions would be a challenge. We wondered how we could encourage peer-to-peer learning through annotations. We thought maybe if an instructor modeled behavior, it would get other students to engage. We wondered, though, if modeling behaviors would sustain interactions. In other words, if an instructor answers a student's question, will this encourage other students to answer questions posed by their peers? Will students who had their questions answered pay it forward? Will answered students ask follow-up questions later or indicate some understanding of the instructor response? How do we light and fan the flame of conversation that transfers and increases knowledge and understanding? This is our naive grading policy. There is very little strategy here for creating and sustaining student engagement in conversations and hypothesis annotations. Students mainly focused on the highlighted portions, which impact 15% of their grade. They said to themselves, to earn a good grade, I need at least 10 meaningful annotations for each of 3 articles and a summary article. Each item is weighted equally. You will see from the data how I know they focused on these highlighted portions. You can think of this strategy and the results as a baseline for future improvement. Here's how much data we analyzed. 3 primary literature peer-reviewed articles were assigned. The first article explored the impact of higher solids loadings on the community of a thermophilic anaerobic switchgrass digester. The second article introduced a commonly used binning application called Metabat2, and the third article investigated the sediment microbial community response of the deep sea horizon oil spill. Students annotated the articles individually before the end of the weekly modules, usually providing 10 annotations per article to obtain full credit. With a total of 13 students, there were approximately 390 annotations to analyze. A natural student effort perspective is reflected in the data. We required at least 10 annotations for full credit, so most students gave us 10 annotations for most articles. Students are probably thinking, why do more than I have to, especially during a pandemic? It's a shortened semester, so I'm swamped with assignments from other classes. I want the grade though, so I'll do the 10 annotations. One of the things I noticed about student annotations is they often ask questions. I wondered how many annotations are questions. To answer this question, I used an Excel formula to search for question marks in the annotation data we tabulated using crowd layers. That's spelled CROWDLAAERS. Here you can see that all students used questions for their annotations, and most students with most articles made inquiries for all their annotations. Unfortunately, most questions were not met with answers. There was a lack of conversations because most annotations remained single questions. This was true for articles with and without instructor intervention. In terms of effort, this makes sense. It's easier to ask a question than answer one. It's easier to ask a question as you are reading text you have to read than it is to read other people's annotations that are not part of the assignment, reading and responding. Here's an example of a rare conversation event. Don't worry about reading the text at this point. Just notice the dates. Student 1 asks a question on October 9th. I answer a question on October 9th. A second student asks a question on October 14th. I answer the second student's question on October 14th. And at the end of my response, I ask if my answer makes sense. Does either student acknowledge my responses to their questions? No. The single dates of student responses are ubiquitous. Students sign in once, give their 10-question annotations, and they move on to the next assignment. It's not a conversation, it's checking the box. Now let's dig into the annotations. The conversation is in regards to an article that has characterized a natural community of thermophilic anaerobic switchgrass digesting organisms, and authors have commented that their results will provide a baseline for future pure culture studies with engineered microbes. Student 1 asked, would it be more effective to use a single type of organism to break these compounds down, or would it be more effective to have multiple working in tandem? I respond positively, my favorite question so far. Systems like these show us that functions have been specialized. Some organisms are primary fermenters, while others are syntrophic. What they are alluding to is a goal of comparing performance of a highly engineered primary fermenter and possibly some other carefully chosen organisms, designed consortia, to compete against a natural fermenting microbiome community. I'm not aware of a way to determine if a student saw the response, whether they learned from my answer, or if they even cared to know the answer. Much is left wanting from a professor's perspective, but more importantly, it brings into question the quality of learning that comes from the way we framed these assignments. You can see the pattern again with student 2. They ask, is designing a consortium more preferable to industry than a natural microbial community? I can see the appeal of designing a community that fits specific needs, but I feel like that only works with microbes that have been extensively studied. It is hard to tell if the student here even read the first student's question and my response to the first student's question. The student may have just added their inquiry to the same region of text. I responded, though, the approach I would take is performing microfermentations in a partial factorial design to see which isolates perform best together. The isolates would include representatives from different functions, primary fermenter, syntroph, thanogen, etc. Taking this approach would only necessitate isolates and taxonomy, usually good enough for functional prediction, not knowledge of each individual's performance, and certainly not knowledge of each individual's performance for each specific culture/industrial condition. Make sense? Another useful feature of Hypothesis is the ability to tag text. If an ontological strategy were applied, tagging could be extremely useful for researchers collecting references for manuscripts. Most of our students were graduate level, writing research papers themselves, so this feature indeed could have been a good habit to get into. Analyzing our crowd layers tabulated data again, we found that half of the students used tags. Student number 5 used tags of their annotations for all of their articles. They were a champion of tagging, in one sense generating 30 out of the total 62 tags. However, when I sorted the tags by frequency and student, student 5 only used one tag more than once, microbial niche. The only other tags used more than once were data collection, used by one student twice, and limitation, used by 3 different students. Furthermore, some tags had just slight variations, like differences in capitalization, spelling errors, or commas. Tags become valuable when there is some purpose for cataloging. In our case, an obvious ontology would revolve around the topic of metagenomics. Tags like aliphatic, BP, oil spill, organic acids, lignocellulose, PAHs don't really fit necessarily with metagenomics theme. As instructors, we could have better helped students see the value of tags and tag conventions in article annotation. The effectiveness of our grading policy and instructor modeling and helping students learn with Hypothesis led us to try to think of data-driven solutions. We came up with 4 strategies to improve conversations, which allow us to measure learning. The first strategy is called Conversation Groups Strategy. Our data showed that students will ask questions if not assigned to do something else. But good conversation includes more than just questions. Try dividing students into groups that ask and answer questions. Additional groups could include supporting documents, reinforcers, and contesters. The second strategy is called daily annotation limit strategy. We saw that students will only return to an article more than once if they have to. Try limiting the number of annotations students are allowed to provide per day. This can also be tracked with crowd layers and Excel for easy grading. Strategy 3 is called tag voting strategy. Adding tags to annotations can help student scientists catalog and remember key aspects of journal articles, making referencing further manuscripts easier months or years later. Try having a discussion about controlled vocabulary and ontology based on course subject. Split students into at least 3 groups. 2 or more groups will provide 3 to 5 tags for each article and 1 to 3 key article sentences that support each tag. One group will vote which 3 to 5 tags get points and comment why they selected certain tags. Offer groups the opportunity to reason with the voting group by responding to voting explanation comments. Allow the group whose tags were originally voted for to defend their earnings. Request that voters make their final decisions with comments. In the last 3 strategies we shared, the student motivation that we leverage is grades. These are heavy-handed methods to promote engagement. One high-impact, low-touch method for instructors to create conversation without a grade-based reward is by seeding an article with questions in annotations prior to article assignment. The thought is that students may answer these out of a habit of answering questions on other assignments. They may be captivated by the question before they have a chance to think of their own. A potential downside to this strategy is that answers will likely come mostly from previous knowledge. A remedy to this downside could be to hybrid this strategy with the conversation group strategy and add fact-checking as a group function. Absent of grade-based motivations, it is challenging to find strategies to engage students in discussion. We would like to find ways that instructors can get involved and model behaviors that will spark a flame for sustained annotation. The question is still open. More ideas, implementation, and evaluation of strategies are needed. Would you please contribute your strategies, either vision or successful implementations, to our Google Doc? The URL is https://go.ncsu.edu/hyp21. In this presentation, I explained how our education team assessed student annotation behaviors, how conversation metrics are a way of evaluating impact of instructor intervention, and how you can design a hypothesis annotation assignment to promote student engagement and learning. Here are some relevant references for further reading on this subject. Finally, we would like to thank our students for their energy, questions, and willingness to learn. Our study was approved by the NC State University Institutional Review Board, IRB number 20309. Dr. Carlos Goller was supported by the North Carolina State Biotechnology Teaching Program. Goller is a Palm Fellow mentored by Dr. Davida Smith. Palm is funded by NSF RCN Award number 1624200. Thank you for listening to this presentation, and we hope it helps with your teaching experience.